in the rugged heart of Montana's high country, where the jagged peaks of the Rockies scrape against a vast big sky, a mystery was unfolding that threatened the very soul of the wilderness. For decades, the elk herds of Montana were the gold standard of North American wildlife, a symbol of resilience and untamed power. But suddenly, something shifted. Hunters, hikers, and rangers began to notice a chilling trend. The massive herds weren't just thinning out, they were vanishing. In some regions, elk numbers plummeted by over 70% in a matter of years. Initial theories pointed toward the usual suspects like wolves, grizzly bears, or even harsh winters. But when biologists went into the field to perform a deep forensic deep dive, they realized the predators weren't the primary cause. They began to look closer at the environment, eventually turning their attention away from the animals and down toward the very ground they walked on. What they found hidden in the soil of Montana's pristine valleys was something far more persistent and terrifying than any wolf pack. It was an invisible, indestructible force that was rewriting the biological code of the landscape. Today we are exploring the silent crisis of the Bitterroot and beyond, and the discovery of a subterranean threat that could change the face of the American West forever. To understand the gravity of the disappearing elk, you first have to understand what an elk represents to Montana. They are the ecosystem's primary engineers. Their grazing habits shape the vegetation. Their migrations create massive nutrient transfers across hundreds of miles, and they are a vital food source for almost every major predator in the region. When the elk population began to crash, it wasn't just a concern for wildlife enthusiasts. It was a signal that the foundational health of the mountains was breaking down. Biologists first focused on recruitment rates, which is basically the number of calves that survive to adulthood. In many areas, the recruitment rates were near zero. Calves were being born, but they weren't making it past their first few months. Early on, the finger was pointed at the reintroduction of gray wolves. It seemed like a logical connection. You bring back a top predator, and the prey disappears. But the data didn't line up. In areas where wolf numbers were stable or even declining, the elk were still vanishing. Even the most aggressive mountain lions and grizzlies couldn't account for the sheer scale of the population drop. The biologists realized they were looking at the wrong part of the equation. They needed to stop looking at what was eating the elk and start looking at what the elk were eating. This led them to a multi-year study of the forage quality across Montana's majestic Bitterroot Valley. As they analyzed the vegetation, the grasses, the shrubs, and the willow shoots, they found that the plants appeared healthy on the surface, but they were nutritionally hollow. However, the real breakthrough happened when they started testing the soil beneath these plants. They weren't just looking for minerals. They were looking for pathogens. Using advanced genomic sequencing, they discovered that the soil in these high-altitude elk habitats was saturated with a specific type of protein that shouldn't have been there. It wasn't a bacteria, and it wasn't a virus. It was a prion. Specifically, it was the agent responsible for chronic wasting disease, or CWD. For those who haven't heard of it, CWD is a neurological condition that affects cervids, which include deer, moose, and elk. But what makes it truly terrifying, and what baffled the Montana biologists, is how it survives. Unlike a normal disease that might dissipate after the host passes away, prions are essentially indestructible. They aren't alive in the traditional sense, so you can't use traditional methods to get rid of them. They can survive being frozen. They can survive extreme heat, and they can bond with soil particles like clay for decades. The biologists found that these prions weren't just sitting in the soil. They were being absorbed by the plants. The elk weren't just catching a disease from each other. They were literally eating it out of the ground. This discovery changed everything. It meant that the entire landscape had become a biological minefield. When an elk grazes on a patch of grass that has absorbed these prions, the proteins enter their system and begin a slow, unstoppable process of misfolding other proteins in the brain. It can take years for an elk to show symptoms, but once the process starts, it is a one-way street. The elk lose their coordination, their sense of fear, and eventually their ability to eat. They become what locals call ghost elk, wandering listlessly through the woods until they succumb to the elements or predators. But the terrifying part isn't just the effect on the individual animal, it's the persistence in the environment. Scientists found that even in areas where elk had been absent for years, the soil remained infectious. The prions bind to clay particles and minerals, staying viable for an estimated 16 years or more. This created a nightmare scenario for conservationists. You can't just relocate the elk to a different valley, because if that valley is also infected, the cycle continues. You can't clean the wilderness. We are talking about millions of acres of rugged, inaccessible terrain. How do you disinfect a mountain range? The impact on the Montana herds has been devastating, as the prions spread through the soil, primarily through the saliva, urine, and remains of infected animals. The hot spots of infection began to merge. Biologists found that the elk's natural behavior was actually working against them. Elk are social animals. They gather in large herds to protect themselves from predators. But in a prion-infected landscape, this social behavior turns every gathering into a superspreader event. They lick each other, they graze on the same patches of grass, and they congregate at watering holes where the soil is often most concentrated with pathogens. The research then moved into a fascinating and dark direction. Scientists began to realize that the ecology of fear we often talk about, where predators keep prey healthy by making them move, was actually being exploited by the disease. When a wolf pack chases an elk herd through an infected valley, the elk are urinating and salivating more due to stress, shedding more prions into the soil. The predators are inadvertently helping to sow the seeds of the disease deeper into the landscape. It is a perfect, tragic loop of biological degradation. What really unsettled the researchers was the stability of the prions. In lab settings, they found that common disinfectants, even high concentrations of bleach, often failed to neutralize them. The only way to truly destroy a prion is through extreme incineration at temperatures exceeding 900 degrees Fahrenheit. Obviously, you can't do that to a national forest. The realization was sinking in that Montana was facing a permanent shift in its biological reality. The soil, the very foundation of life in the West, was now a carrier for a condition that could potentially last for generations. The mystery of the disappearing elk started to make sense through this lens. If the calves were grazing on infected ground from day one, their chances of reaching adulthood were slim. Even if they didn't show full neurological symptoms, the subtle degradation of their cognitive abilities made them much easier targets for wolves and bears. The predators weren't the cause of the decline. They were just the ones finishing it. The real struggle was happening on a molecular level, hundreds of feet below the canopy, in the interplay between clay particles and misfolded proteins. But the scientists didn't stop at just identifying the problem. They started looking for solutions, and that led them to some of the most cutting-edge research in modern biology. They began to investigate certain types of soil microbes and fungi that might have the ability to break down proteins. In some small-scale tests, they found that specific enzymes produced by wood-rotting fungi could actually degrade prions. This provided a glimmer of hope. If we could encourage the growth of these fungi in the wild, perhaps we could facilitate a natural cleaning of the soil over a much longer period. However, applying this on a scale as vast as Montana is a monumental challenge. It involves rethinking forest management entirely. Instead of focusing on timber yields or fire prevention alone, we have to start thinking about biological remediation. This might mean changing how we handle forest debris or how we manage water runoff. Every stream that flows off an infected mountain carries the risk of transporting prions to the valleys below. The scale of the logistics required to manage this is hard to wrap your head around. It is an engineering challenge disguised as an environmental crisis. The economic implications for Montana are massive. Deer and elk hunting bring in hundreds of millions of dollars to the state every year, supporting rural communities and funding conservation efforts. If the herds continue to vanish, that entire economy ripples and collapses. But more importantly, there is the question of cross-species transmission. While there is currently no evidence that CWD can affect humans, scientists remain cautious. They point to mad cow disease in the UK in the 90s as a reminder of what happens when we underestimate the ability of prions to jump the species barrier. Testing elk meat has become a top priority in Montana, with specialized labs working around the clock during hunting season to ensure that the ghost elk don't end up on anyone's dinner table. The discovery in the soil has also changed how we view land value. Real estate in the American West is often prized for its proximity to wildlife and hunting grounds. But if a piece of land is hot with prions, its value is fundamentally altered. We are entering an era where biological surveys of the soil might become as common as water rights assessments. It is a fundamental shift in how we interact with the land. As the study continued, biologists found that some elk were showing a natural resistance to the disease. A very small percentage of the population seemed to have a genetic makeup that prevented the prions from taking hold as easily. This has become the center of a new conservation strategy. By protecting these resistant individuals, we might be able to help the elk population evolve its way out of the crisis. It's a race against time. Can the elk adapt faster than the prions can spread? The story of the Montana elk is a warning for all of us. It's a reminder that we don't always understand the consequences of how we manage our wild spaces. For years, we thought we could control nature by managing the things we can see: the trees, the wolves, the hunters. But we ignored the invisible world beneath our feet. The prions may have been lingering in the soil for much longer than we realized, possibly introduced through commercial deer farming or the movement of carcasses across state lines. It is a reminder that in our modern hyper-connected world, a biological mistake in one place can become a permanent feature of the landscape elsewhere. In the valleys of the Bitterroot, the work remains intense. Scientists are deploying soil sensors and using drones to map the health of the vegetation with hyperspectral imaging. They are trying to find the superspreader sites like communal salt licks or watering holes to see if they can be fenced off or treated. Every small victory is celebrated. If they can prevent even one herd from being exposed, it's a win. But they are fighting an enemy that doesn't sleep, doesn't eat, and can wait for 16 years in the dirt. The resilience of the elk is being tested like never before. They are moving into higher, more isolated territories to avoid the infected lowlands. This is changing the migration patterns that have existed for 10,000 years. We are seeing a complete reshuffling of the wilderness. Predators are following the elk into these new territories, which is causing tension with local ranchers who haven't dealt with wolves or bears in decades. The ripples of the soil discovery are felt in every corner of Montana life. What is happening in the soil of Montana isn't just a local problem. CWD has been detected in over 25 states and several Canadian provinces. It is a continental crisis. But Montana is where some of the most radical research is happening. By focusing on the soil rather than just the animals, Montana's biologists are providing a blueprint for how we might manage this across the planet. They are teaching us that to save the wildlife, we have to save the ground they stand on. The research into fungi remediation is particularly exciting. Imagine a future where we seed our forests with specific mushrooms meant to neutralize pathogens in the soil. It sounds like science fiction, but it might be our only choice. It's a shift from being protectors of the forest to being healers of the soil. This requires a level of biological engineering that we are only just beginning to master. The ghost elk continue to wander the ridges, a haunting reminder of what's at stake. Each one that succumbs to the disease contributes more prions to the soil, continuing the cycle. But for every ghost elk, there are others that are still strong, still resilient, and still fighting. The biologists are working day and night to ensure that these survivors have a future. They are the guardians of a genetic treasure that might be the key to the survival of the species. The discovery of prions in the plants themselves was perhaps the most terrifying part of the biologists' findings. Ordinarily, we think of plants as a barrier, something that translates sun and soil into clean energy. But finding that common forage plants can actually uptake and hold infectious prions means that the entire food web is compromised. It's not just the soil, it's the salad. This has huge implications for agricultural land that sits near wildlife corridors. If elk or deer are shedding prions on a field of alfalfa or hay, can that hay then spread the disease to cattle or other livestock? So far, the species barrier has held, but the concern is always there. Scientists are now exploring the use of high-intensity ultrasound and even certain types of clay minerals that can trap and neutralize the proteins. It's a war of attrition. We are throwing every piece of technology we have at a piece of protein that doesn't have a brain, a heartbeat, or a life cycle. It is the ultimate test of human ingenuity against the raw, indifferent persistence of nature's darker side. The Bitterroot Valley remains a place of stunning beauty, but for those who know the secret in the soil, that beauty is now tinged with a sense of urgency. You look at a pristine meadow and you don't just see a place for elk to graze. You see a potential reservoir for a disease that could outlast our civilization. It changes your perspective on what clean and natural really mean. The biologists' work in Montana is a masterclass in modern ecological detective work. They didn't accept the easy answers. They didn't stop when they found the wolves. They kept digging, literally, until they found the truth. And that truth is that the health of our wildlife is inextricably linked to the health of our soil. We cannot ignore the subterranean world and expect the surface world to thrive. The disappearing elk of Montana are a call to action. They are telling us that we need to invest more in soil science, more in prion research, and more in radical forest management. We need to be as persistent as the enemy we are fighting. The 400 wolves of Yellowstone changed the rivers, But the prions of Montana might change the very chemistry of the mountains. As we follow the biologists into the next phase of their research, we see them testing new biofilters in the streams and looking for ways to boost the elk's natural immune response. There is a sense of community among the scientists. They are sharing data across state lines, working with federal agencies, and engaging with the public. They know that this is a fight that can't be won in a vacuum. It takes an entire society to protect an entire ecosystem. The mission is clear: protect the herds, heal the soil, and ensure that the elk remain a part of the American West for the next 10,000 years. It's a mission that requires patience, courage, and a willingness to face a terrifying reality head-on. The elk are disappearing fast, but they aren't gone yet. And as long as there are people willing to dig into the dirt to find the truth, there is a chance for a comeback. The high country of Montana is a place where legends are made. The legend of the elk has always been about strength. Now it's about a different kind of strength, the strength to survive a hidden, invisible threat. The biologists have found the enemy in the soil, and the battle is joined. It's a struggle for the soul of the wilderness, and it's happening right now, beneath the big sky and the jagged peaks of the Rockies. Every soil sample taken, every elk tagged, and every fungal spore seeded is a step toward a solution. We are learning to coexist with a landscape that is more complex and more dangerous than we ever imagined. But in that learning, we find a new kind of connection to the earth. We are becoming its stewards in the truest sense of the word, looking after the microscopic and the monumental alike. The ghost elk might still walk the bitter route, but they are no longer a mystery. We know who the enemy is, we know where it hides, and we are starting to learn how to fight back. The story of Montana's elk is a reminder that even in the face of a terrifying discovery, human knowledge and determination can provide a path forward. The elk may be disappearing fast, but they have some of the smartest, most dedicated people on the planet fighting for them. As the sun sets over the mountains, casting long shadows across the valleys, the bugle of a bull elk echoes through the trees. It's a sound of defiance. It's a reminder of why we are doing this. For the elk, for the mountains, and for the future of the American West. The secret in the soil has been revealed, and now the real work begins. We are gardeners of the wild, protectors of the protein, and guardians of the ghost elk, and we aren't going anywhere. The next time you see a herd of elk, take a moment to look at the ground they are standing on. Think about the silent dance of minerals and microbes happening beneath their hooves. Think about the scientists in Montana who are out there right now, digging in the dirt to protect that harmony. The wilderness is a precious, fragile thing, and it belongs to all of us. Let's make sure we're doing our part to keep it healthy, from the highest peak to the deepest grain of soil. The Montana Elk Project is a testament to the power of recent scientific discoveries. It shows us that moving beyond the obvious can lead to truths that change the way we see the world. It's a journey from the visible down to the molecular, and it's a journey that is still ongoing. The soil is telling us a story, and we are finally learning how to listen. In the end, the disappearing elk of Montana aren't just a biological statistic. They are a mirror for our own survival. If we can solve the mystery in the soil, if we can protect the herds from the prions, we will have learned something fundamental about how to navigate the challenges of the 21st century. We are all connected, from the dirt to the sky, and in that connection lies our greatest challenge and our greatest hope. The work in the Bitterroot continues. The elk move on, the soil remains. But something has changed. We are no longer in the dark. The invisible threat has a name, and because it has a name, it can be fought. The future of Montana's elk is in our hands, and with the help of biology and a little bit of fungi, we just might see a miracle in the mountains. Thank you for joining us on this deep dive into one of Montana's most pressing environmental mysteries. The story of the soil and the elk is a reminder that nature is never as simple as it looks on the surface. Stay curious, stay informed, and always keep an eye on the ground beneath your feet. The next legendary discovery is usually just a few inches down. Until next time, stay connected to the wild and stay part of the solution. The elk are waiting for us.